Good morning to you all. I want us to solve this past question. Thus, Advanced Calculus 1, Quiz 1, 2023. So let's start with the first example. The first question. Find the domain of the function f of xy equal to this. Now when we say domain, the domain for the function, to determine the domain, this is a rational function. The denominator is not supposed to be 0. So you only have to say that the denominator shouldn't be 0. So y minus x should not be equal to 0. And that means that y shouldn't be equal to x. So the answer is D. Describe the range of the function f of s, y equal to s squared plus y squared. Now when we talk of range, we are looking at the dependent variable, that is z. Let's say f of xy is z. Now we know that z is equal to s squared plus y squared. Now s squared is a perfect squared, y squared is also a perfect squared. It means that whether you put in negative values or positive values or even 0, you will still get a solution to the function. Therefore, the range is defined on all real numbers, and that is from negative infinity to positive infinity. The answer is D. Evaluate the limit. Evaluate the limit as xy is approaching 4, 1 of the function f of xy, where f of xy is equal to 4x. So here, if f of xy is equal to 4x, then we can put 4x here. Then it becomes the limit as xy is approaching 4, 1 of 4x. Now x is 4. So wherever you see x, you put 4 there, and the answer is 16. Evaluate this limit. So the same thing, f of xy is giving us 7 minus y, so we will put it here. Then it becomes the limit as xy approaches 3, 5 of 7 minus y. Now look at the y value. The y value here is 5. So we only put 5 here, then we get 2. So the answer is 2. Here we are to calculate the limit as xy approaches 1, 3 of this function. Now, let's do direct substitution. So we put in wherever we see s, we put 1 there. Wherever we see y, we put 3 there. So we'll just do the substitution here, and we will get 0 over 4, which is 0. So the answer is 0. Evaluate the limit as s, y is approaching 0, 0 of this function along the path x is equal to y. Now here, when you do direct substitution, you will get 0 over 0, which is indeterminate. So we are asked to evaluate it along a given path, which is s is equal to y. What it means is that wherever you see y, you substitute x there. So you have 2x times x, 2x times x, then we have s squared here, then the y squared 2 will become s squared. Now here becomes 2s squared, then here will also be s squared plus s squared is 2s squared, which can cancel out. So we have 1 as the answer. Let's go to question 7. Determine the set of points at which the function f of s, y equal to s squared plus y squared all over s squared plus y squared minus 18 is continuous. Now for the function to be continuous, it means that it must be continuous on its entire domain. therefore we must find the domain of this function. Now, for the function to be defined, the denominator of this function shouldn't be 0. So x squared plus y squared minus 18 must not be equal to 0. This implies that x squared plus y squared shouldn't be equal to 18. Now we can write the right hand side, the 18, as two functions, 9 plus 9, where we know that 9 is the same as plus or minus 3 squared. Plus or minus 3 squared. So by comparing, x squared plus y squared is the same as plus or minus 3 squared plus or minus 3 squared. So what it means is that our x is plus or minus 3 and our y is plus or minus 3. And that means that x shouldn't be equal to plus or minus 3, y shouldn't be equal to plus or minus 3. That is the only case for which the function will be continuous, and that is C. Suppose that the limit xy mapping onto 3, 1 of the function f of x, y equal to 8. If f of xy is continuous at the point 3, 1, then we have to find f of 3, 1. Now, we can answer this question based on the theorem that if a function f of xy is continuous at a point AB, then the limit as x approaches that point AB of the given function must be equal to the same function putting in the point AB. So if that be the case, then it means that since the limit as sy is approaching 3, 1 of the function is giving us 8, and because the function is continuous, then it means that f of xy, that is f of the point 3, 1, must be equal to 8 based on the theorem. So the answer is 8. If f of xy is equal to sine x cubed y squared, then we have to find the first, the partial derivative with respect to x. So what it means is that we need to differentiate sine. When we differentiate sine, we will get cos x cubed y squared. Then we must multiply it by the derivative of the inner function with respect to x. With respect to x, we treat the y squared as a constant and focus on the x cubed. When you differentiate the x cubed, you will get 3x squared, and it will multiply the constant y squared. So the correct answer is supposed to be 3x squared y squared cos x cubed y squared. We can see that none of the answer here corresponds to that, so there is no answer to this question. Good. So let's come to question 10. If f of x, y equal to g to the power xy, we have to find the derivative of the function with respect to y. So we know that this is an exponential function. When you differentiate, you still get the same exponential function. Then you multiply by the derivative of the exponent with respect to y. So we treat x as a constant, and we will get x. So we have f of y should be equal to this as the answer. Find the second partial derivative of this function. So here, what it means that first we must differentiate with respect to x, then second with respect to y. So let's take the first order, differentiating it with respect to x. This is taken as a constant. So when you differentiate a constant, you get 0. Then here, we are differentiating with respect to x. When you differentiate x, you get 1. 1 times the constant y is y. So you get 0 plus y. Then you differentiate again with respect to y. When you differentiate 0, it's still 0. When you differentiate y with respect to y, you get 1. So the answer is 1. If z is equal to f of x comma y equal to y squared x, we should find the differential dz. Now dz is given as the partial derivative of f with respect to x, multiplying it by dx, plus the partial derivative of f with respect to y, multiplying it by dy. Now therefore the differential is given us, we need to find the partial derivative of f with respect to x. With respect to x, y squared is taken as a constant. When you differentiate the x, you get 1. 1 times the y squared is y squared. Then it will multiply the dx. Plus, now differentiating with respect to y, we treat the x as a constant. With respect to y, we treat the x as a constant. Then we differentiate y squared. When you differentiate y squared, you get 2y. Then it will multiply the x to be 2yx. Then you multiply it by the dy here. So that becomes the solution. That is B. 13. If z is equal to xy, where x is equal to 4t and y is equal to t squared, then we have to find z dt. Here we are applying the chain rule, which says that dz dt should be equal to dz dx times dx dt plus dz dy times dy dt. So dz dt will be equal to, when you differentiate dz dx, you get y. We are partially differentiating z with respect to x. So y is a constant. You differentiate x1. 1 times y is y. Then when you come to dz dy, we are differentiating with respect to y. So we also treat s as a constant. When you differentiate y, you get 1. 1 times x is x. Then we come to dx dt. dx dt, when you differentiate x with respect to t, you get 4. And dy dt, when you differentiate y with respect to t, you get 2t. Then you substitute each of them into the formula. Then that becomes the answer. That's D. 14. Find the chain rule for dw dt if w is the dependent variable, is equal to f of xy. Here the xy is the intermediate variables, where x is also equal to ts and y is also equal to ts. The ts are the independent variables. So you start with, we are using the tree diagram. You start with the dependent variable, which maps onto x and y, and the maps onto the dependent variable maps onto the intermediate variables x and y, and the x and y also maps onto the independent variables t and s. So from here we can find a partial derivative of w with respect to s, x with respect to t, w with respect to y, then y with respect to t, y with respect to s. So after you have done all the partial derivatives, what is the question asking us to find? To find the w dt. Now you know that from w to t, you must pass through this lane. That is going to be the w dx times the x dt. The w dx times the x dt. Or that is plus. You can also go to, from w to t, you can pass through here and here. That is the w dy times dy dt, and that is the chain rule. Alright, the answer is D. So let's go to 15. Find dy dx if x plus y squared is equal to 5xy. Now remember that if you have a function of two variables, that is z is equal to f of xy Implicitly, to find the partial derivative of z with respect to x, it becomes negative the partial derivative with respect to x over the partial derivative with respect to the dependent variable z. Similarly, if you want to find the partial derivative of the dependent variable z with respect to one of the independent variables y, then it is equal to negative the partial derivative with respect to y over the partial derivative with respect to the dependent variable z. So using this concept, in our case, we are supposed to find the y dx from this implicit differentiation. So we can see that dy dx, in this case, the y is the dependent and the x is the independent. So the formula says negative the partial derivative of the independent, which is x, over the partial derivative of the dependent. So all what we need to do is to group like terms by bringing the 5xy to the left hand side to be this. Then we take f of x, which is the partial derivative with respect to x. When you differentiate with respect to s, you get 1. The y squared is treated as a constant, is 0. And when you differentiate negative 5xy with respect to x, you get 5y. So that is for the f of x. Then the f of y, differentiating with respect to y, x is a constant, so 0. Then the y squared becomes 2y. Then differentiating with respect to y, y will be 1. Then times the 5x. Differentiating with respect to y, we will have, we will treat the x as a constant. So we will have 5, let me check it well. Differentiating with respect to y here, it means that we are treating the 5x as a constant. So when you differentiate 5y, you are supposed to get, it's supposed to be 5x. Let me correct that part. Here is supposed to be 5x, not 5y. 5x. Okay. Let me look at it well to be sure of what I'm doing. So the partial derivative with respect to x, here we treat y as a constant. We treat y as a constant. So the x will be 1. Y squared is 0. Then here we differentiate x to be 1. So we will get 5, 1. So this is correct. Now when we come to the 5y, fy, that is differentiating with respect to y, we treat x as a constant, so that will be 0. Then when we differentiate y squared, we will get 2y, then minus, here we are treating x as a constant. So since x is a constant, we focus on the 5y. So we have 5xy, and we are differentiating with respect to y. So when you differentiate 5y, you will get, I'm coming. Yeah, so since we are differentiating with respect to y, it means that the 5x is treated as a constant. So we hold that 1, then we differentiate y, we will get 1. 1 times 5x is 5x. So it's supposed to be this. It's correct. So now we substitute it into the formula as 1 minus 5y, then all over 2y minus 5x. Okay, so here was supposed to be 5x. 5x. Okay. 5x. So the answer is A. It's still correct. The answer is A. Alright, so let's go to 16. Find the degree of homogeneity of the function f of xy equal to root of x to the power 4 plus 3y to the power 4. So here, before we find the degree of homogeneity, we are supposed to translate x to kx. where k is a constant and y to also kx. So it means that wherever we see x, we will substitute kx. Wherever we see y, we substitute ky. So we will have this kx into brackets, exponent 4, 3 into brackets, ky to the power 4. Then we expand k to the power 4, x to the power 4, 3, k to the power 4, y to the power 4. So we have the square root of k to the power 4, x to the power 4. We can factorize the k to the power 4 out to get back the original function, x to the power 4 plus 3y to the power 4. Then we apply the square root for both terms. Square root of k to the power 4 is k squared. Then root of x squared plus 3y squared. Remember that this is the original function. Therefore, the exponent here becomes the degree of homogeneity, which is 2. So the answer is C. Now, we are supposed to use the following information to answer questions 17 to 19. Now, we have been given that the Jacobian is 4798. But remember that the formula for finding the Jacobian is dx du, dx dv, dy du, dy dv. So you can compare. The question says find dy dv. So dy dv will be 2. This part 2. And that is the answer. When you compare, dy dv is this. Dy du is 9. The x du is 4. The x dv is 7. So our dy dv is 2. Then the next question, 18. The x du. We know that the x du is 4. So the x du is 4. Then 19. We are supposed to find the x dv and the y du. Now we know that the x dv is 7. The x dv is 7. And dy du is 9. Dy du is 9. Then the question says we should find the product of the two. So we multiply this by this. Then we get 63. So finally, question 20. We are supposed to find the partial derivative with respect to y of this function. We are differentiating with respect to y, so we treat s squared as a constant. We treat the s squared as a constant. So when you differentiate y, you get 1. 1 times s squared is s squared. Then because it is length, you divide by the original function inside, which is s squared y. The s squared will cancel itself 1 and cancel s squared. And you have 1 over y as the answer. So thank you for watching this video. Take your time to go through it, understand the concepts. Wishing you good luck.